Now we are going to discuss about a theorem based on the area of a triangle. So first we'll discuss about the statement of the theorem. What does the statement says? If a vector comma b vector represent the adjacent sides of a triangle, represent the adjacent sides of a triangle, then its area is then its area is given by half of the magnitude of a cross b. This is called the statement of the theorem. In order to prove this theorem, we'll take the triangle in such a way that this is the triangle which you are going to use in order to prove this theorem. Let this vertex is A, this is B, while this is known as C. The vertex is from A to C and the other one is from A to B, while the next one is from C to B. Now you draw a perpendicular from C to AB. We'll call that point as D. That AC is denoted by A vector, while AB is denoted by B vector. Now, what are the things on the diagram? We'll write it here in such a way that let AC vector is equals to A vector, while AB vector is equal to B vector. Now, for our convenience, we will assume the angle between AC and AB as theta. That is, let angle between A comma B is equals to theta. So we'll do a small construction here, that is draw CD perpendicular to AB. CD vector perpendicular to AB vector. Now we'll write the area of a triangle. So the area of a triangle is equals to half into base into height. That is half into AB into CD. That is, we'll write it as B dot A, because AB is denoted by B while CD is denoted by A. But CD, if you want to get it, we will write it as half into magnitude of B into magnitude of A into sine theta. Right? But how to get the value of A here? The thing is, in the triangle ADC, we will apply the sine theta, that is opposite side by hypotenuse, that is CD by magnitude of A. Right, now this can be written as half of magnitude of B into A into sine theta, that is half of A cross